Here we'll talk about neural nets. If you've been conscious lately, you've heard about neural network learning in the context of artificial intelligence, AI. Whether in image recognition, is this a picture of a cat? Speech recognition, Alexa, what's the weather tomorrow? And LLMs. Hey, ChatGPT, would you enslave humanity? I won't go into detail here. The field is huge and rapidly expanding in lots of different areas. But you can quickly learn the basics. Both cost and benefits are really large in these models. Costs are large since they have a huge number of parameters to estimate and need huge amounts of data to train. All of these interlocking estimations take a lot of knob twiddling and computation, but they're very useful. The models were originally developed to recognize handwritten numbers. The US Post Office wanted machines to be able to read the zip codes on letters instead of having done by humans. But the range of application has grown a lot since then. The structure of a neural network starts with all the input values on the left-hand side. Those are restricted to all between 0 and 1, so they're standardized. The model outputs some values on the right-hand side. I'm just showing 2, but there can be many more. In between are hidden layers. The number of layers and the number of nodes within each layer are hyperparameters that we can set. Obviously, that can be further tuned, just like our previous model had hyperparameters that can be tuned for specific tasks. Each node takes in a bunch of values and outputs a number between 0 and 1. Each node's input-output function is not linear. That's one of the strengths of this model. If it were linear, we could compact it down, but the nonlinear relationship between each node's inputs and output gives that complexity. That sounds fancy, but we've already seen a class of models that take in a bunch of values and output something between 0 and 1, logit models. Each node in the model is often just a logit. So while models like LLMs are often presented as effing magic, and their abilities to handle complex problems do sometimes seem amazingly awesome, at base they're could be a big collection of logit models. I mean, not always logit. Sometimes other functions are used. It's an obvious change to be explored. But estimating all these logit models is really complicated. As previous picture showed, there are a lot of connections. Any change to one node will propagate through the whole model. It's a good thing computers are really fast at doing computations. The original idea of a neural net was that it was like how animal neurons worked. That was decades ago. Since then, the field has added a great deal more complications. So if you want to know how our own brains work, go talk to one of the neuropsychologists here. But we can appreciate a bit of the complexity. We've talked about how a random forest model will take a while to be estimated, and that's just a bunch of tree models which are individually pretty simple to estimate. And they only got one layer. So we talked about how logit models are more complex to estimate compared with simple linear models. So it won't be surprised to find that a forest of logit models with multiple layers would be tough to estimate. The other intuition that carries over is, we discussed how random forests are difficult to interpret. Why'd the model produce that? Neural nets are even tougher to interpret. I'll give a bit of code, but R is not the preferred method of estimating these models. Go to Python if you really want. But R has a package, neural net, that you can add, and some basic coding following in the usual pattern that we've come to expect. Provide the formula with the dependent variable we want to predict along with the input values. Here are only 4 of them. They got to be standardized properly. You tell it which data set to use. For me and my little laptop, I had to keep that pretty small. Then the hidden piece command tells it how many layers and nodes. This example uses 4 nodes in the first hidden layer and 2 in the second hidden layer. The output provides a picture of the nodes it estimated. Last thing to complicate, I hope this bit of learning helped, but don't fool yourself, it's only a bit. If the metaphor, a forest of logit models, made any sense to you, that's because you've done a ton of learning already. You've already estimated a whole bunch of different models, many parameters and methods. You're already at a level that the you of 4 months ago would have described as effing magic. So congratulations, but keep going.